Hey, what is up, everyone? Michael Crump here, bringing you the latest and the greatest in PlayStation 4, homebrew news, and much, much more. Today I have something pretty cool for you. So let's just go ahead and let's roll the video. I am just about to click Goldhen version 2.1.2 and let's see what happens here. Okay, so it is loading the exploit, telling us to please wait. I know you're just waiting for the USB message to pop up or a bunch of additional alert boxes. And well, this time you're not going to see any of those alert boxes simply because we're going to be doing everything on our ESP32-S2 device. And we're going to be able to get to Goldhen loaded in right around 40 seconds. Okay, so that was very cool how fast that executed. And there is ways that we can actually speed up that performance to where it's even less time than the 40 seconds that it took just right here. Let's see how we can do this. Okay, so before we begin, I wanted to go over a large number of devices that I have tried and I have been working with for the PlayStation 4 jailbreak. I have a video on pretty much all of these. So here is the very first one. This was an ESP32-S2 board. The issue with this board is simply that you cannot do USB emulation automatically with it. Now there is a way, and I'll pop up a diagram for that, if you want to use this board and manually solder a couple of different components together in order to make this automatically do the USB emulation. Now I have went ahead and wired up this to use the automatic USB emulation, and it was very messy. And I'm not simply just talking about the process of soldering, etc. But I'm talking about it requires a bunch of different components that you're going to need to go out and purchase separately. Purchasing those components separately, especially if you don't have them, is going to run up the cost. So I definitely wouldn't recommend it. This right here is the ESP32 device. This device is one that I've also used quite a bit, but it also does not support USB emulation. So I'm no longer using it. My daily driver kind of resorted back over here to my Raspberry Pi Zero. And this device is absolutely great, but there's a couple of problems with this one. Primarily being that you can't actually purchase Raspberry Pis for the retail base price. These components are in demand right now. So what that means is that you can't get a Raspberry Pi if you're willing just to pay retail prices. The only way you can get one is if you're willing to pay inflated prices or join wait list for different Raspberry Pi sites and then order it immediately, which is what I did for this one right here. So this is the newer version of the Raspberry Pi Zero. And this one I had to sign up for a wait list, and then as soon as it opened up, I was one of the first people to get one, and I paid retail price for this. Now, again, just like pretty much any of these things, as soon as it was opened up, 5 to 10 minutes later, there was 0 of these available because it was the retail prices. People are used to paying a lot more for the Raspberry Pi Zeros than what they should have to pay for it. And then that brings us over here to these Wemos S2 Mini board. And I bought 2 of these for some recent tests. This is the ESP32-S2. And so what that means is that USB emulation is baked onto this, so you won't need to wire up or do any type of soldering with that. Another benefit to using these boards is that the availability of these is great, but you are going to wait a while. Right now, AliExpress is one place where I bought these, and there was a little over maybe a month and a week or so wait time to get to me. I'm in the United States, and I will just say is that if you're in the United States and you use AliExpress or some of the places that sell more affordable pieces, you are going to be waiting for some time to get those to you. And while you could obviously try things, such as eBay, I have found really zero suppliers for the United States that could get me this board in a very short amount of time. With all of these boards, there's a whole bunch of different pros and cons to this, but I would say that the S2 Mini, and at least what I learned from my testing for this video, is definitely one of the better ways to go. And that being, number one, it's inexpensive. Number two, it's readily available as long as you're willing to wait. And then number three is that it's pretty easy to hook up and to get going once you know what you're doing. And one of the things just to call out here is that with these Wemos S2 Mini boards, keep in mind that they do not hold very much space. So I believe this is actually at 4 megabytes flash. So what does that mean? Obviously, you'll be able to do things such as have your goldhen.bin, but you'll also be able to put a number of payloads. Will it hold all of the payloads? Absolutely not. But you will be able to bring at least some of your more important payloads with you. Maybe things such as like app dumper or disable updates, or a few of the other ones that you know that you're going to need. And here is a close-up view of that S2 Mini chip. And a few things that you will need to learn here is that number one, this is USB-C. So USB-C is the way that you communicate with this chip versus the USB-A that we've seen with a lot of the other chips that's out there. Another thing is programming these boards is not as easy as it may have been with the ESP8266 or the ESP32, where you basically just plug them into your micro USB cable into your computer and then upload the sketch from the Arduino IDE. It's a little bit more complicated than that. Primarily being that you've got to enter into a DFU mode or a mode that will allow you to write to this board. It's very simple once you figure it out, but it gave me many headaches before. I'll cover that when we get into flashing it. And then again, I just wanted to touch again that this is USB-C, so you will need a USB-C to a USB-A cable in order to get this to connect to your PlayStation 4. So if you are wondering what you get with the board, for the most part, you obviously get the board itself. You get several of the different pins in case you want to connect it to other devices. And so right here is the actual data sheet where obviously it shows the different types of pins, what's your ground, what is your voltage and VBus, etc. And so, yeah, this is pretty much what you get in the package. And there's your USB-C. Okay, so that's the package. Let's go ahead and let's stop there, and let's go ahead and let's start getting this device ready to use with our PlayStation 4. Okay, so just like always, I put a link to all of these down inside of the description below, but we're going to begin by downloading Arduino. So head over to arduino.cc, and this is in the software, and then go to where it says Windows here, and then just download. Again, I'm using Windows here, but just as you saw just a moment ago, you can obviously use Mac or you can use Linux. The next place you're going to want to go to is go to this ESP32-server-900U. So this is by Stooged, which is the one that I have been using pretty much since I've started any of my ESP videos. So you just want to head over here, and you'll note that now this package has been combined. So before there was separate GitHub repos for the ESP32, the ESP32-S2, and then the ESP32-S3. Now they're pretty much all just right here in this one repository, which is very nice because now you don't need to go and especially manage different types of repos in order to get the right bits onto your board. So again, right here, we are using the ESP32-S2, and it says you do not need a USB drive with this project. Now, I will say that there is also these ESP32-S3 boards. I don't have one of these boards. These are definitely in more of this kind of development stage. I wouldn't recommend them at all. I would say if you're going to pick a board today for your PlayStation 4, I would go with something that's an ESP32-S2 board. So go up to code, and then we're going to go download zip, and that should be it. If we scroll down the page here, you're going to see that there's two projects that we need to download. There's one called ESP Async Web Server, and then there's another one here that's just called Async TCP. What we're going to do is we're going to go ahead and we're going to open both of these, which I already have opened, and we're going to just scroll down here, and we can see that these are basically async HTTP and WebSocket servers for these ESP Arduino devices. So we're going to need the one that is async TCP to work because we have the ESP32 board. So this is very easy to take advantage of. Go up to code again and then download zip file. And here is the next one that we're going to need is going to be the async TCP. So again, go into this folder here and then go up to code and then go down to download zip. And at this point, we should have the files that we need. Now, down at the very bottom, you may have noticed this as I was walking through this video, but it did say in the ESP32 server 900U that it says failed virus detected. Now, there is a file that's in there that gives a false positive to the antivirus software. So there's a couple of ways around this. So I typically use git to get around this sort of a message. And we go to code, and then I'm just going to copy this URL right here, and let's switch over to our command prompt. And in our command prompt, I'm just going to go and cd into a folder where I store a bunch of my source code, and you will need to have git installed. I'll also leave a link to Git if you don't already have it on your system, but it's very quick and painless in order to get it installed. So all I do once it is installed is that I simply go git, here I go clone, and then I just paste in that URL, and then I have it now downloaded on my system. So this will bypass the browser controls or the browser security that says that this is a virus. And I can just simply cd into that folder, and we'll do a quick dir, and I can see that the files are located here. And if you're wondering, it is the files that's inside of the bin2h that causes the browser to go a little bit crazy there. If you don't download those, then you're usually okay. But again, using this method, you don't have to worry about that. So I'm going to do an explorer and a period here, and that will bring me back into Windows Explorer. And now I can go into the folder, and there is all of our files. Okay, so what I've done here is, again, I just have a new folder called PS4, and I have just named this folder ESP32-S2. That way I can find it again, and I have just copied over that file that we downloaded in Git over here. I'm going to go ahead and I'm going to copy over the remaining files that we downloaded. So I'm going to paste these in here, and we simply have our Arduino, we have our async TCP, and then our ESP async web server. The main one that we're going to need to extract is going to be the Arduino Nightly Windows. And there we go, it has been extracted here. And so I'm going to go into that folder here. And now I'm just going to go and double click on arduino.exe. Now, by default, when you run this application, if you ever had a file loaded before, it loads that by default. But again, don't worry if you haven't loaded anything before. You should still be in the main Arduino IDE. Now go up to where it says File, and then go down to Preferences, and then where it says Additional Boards Manager URL. So here you're going to want to paste in this URL, which was included in the GitHub, which I'll show in just a moment, but also you can grab this from the description below. And then you're going to want to press on OK down here at the bottom. Let me just go ahead and bring that over here in GitHub just so you can find it. And so again, this is on the main project page, and this is where it has install or update the ESP32 core by adding this URL to the additional board section under preferences. And there is where I got that URL. Now we need to go into the board manager. So I'm going to go tools, and we're going to go down to board and then board manager. And we're going to search for ESP32. Okay, and so there it is. I already have the latest version installed, but if you don't have it installed, this is what you might see. So I'm going to actually select a version that I don't have, and I'm going to go down to maybe 2.01 just so you can see the process, and I'm going to hit install here. And so what it does here is it downloads the platform index, it downloads the rest of the files, and then you should have it available for you to start using. I'm going to go ahead and hit close here. Then you're going to want to go up to Tools, Board, and then ESP32 Arduino. And then up at the top, you should see ESP32-S2 Dev Module. So that is what I used for my Wemos chip, and more than likely, if you have any sort of ESP32-S2 chip, that's the option that you're going to want to select. So go ahead and select that. And then just come down here to where it shows the port. So this port is showing that it is on COM6. And so you want to know what COM port your device is setting on. One of the easier ways to kind of figure that out is by bringing up your device manager here. And once you open up the device manager, you should look down here on ports. Mine is showing USB serial device that's setting on COM6. Now keep in mind, that doesn't mean that COM6 is going to be there forever. As you'll see in just a moment, it actually switched to COM7, at least on my computer, when I opened up this additional instance of Arduino. So this is something you're just going to want to pay attention to. So go ahead and go back to File and then Open again, and let's load in the project that we just downloaded. So I'm going to go to the ESP32_server_900U, and I'm going to select the loader.h file. So this is the project that we will be uploading to our device in just a moment. There's a couple of quick things to keep in mind here. So here is the loader.h. Again, you don't really need to do anything with at least these few pages. So the pages, the exfat.h, the fan.h, and then the goldhen.h. Now with the goldhen.h, you can see right now it's running on Goldhen version 2.1.2. So what happens when newer versions of Goldhen comes out? Well, included inside of this package, in which I alluded to a little bit earlier, there is a folder that will allow you to take the new goldhen.bin files and create the goldhen.h. For the time being, this project already has the very latest Goldhen added to it. But as you all know, I love having the ability to own my hardware, so I like having that ability to create my own goldhen.h file if and when I want to. And so here is the bin2h folder that's included in the project. And this is really as simple as coming down here and it says, this tool allows you to generate goldhen.h file from the goldhen.bin file. So just drag and drop goldhen.bin file onto the bin2h_exe.bat if you do not have Python installed, or you can use the bin2h_python.bat if you already have Python installed. So what happens here is that the bin file is compressed with gzip during the conversion process, which will save space. And then once it is finished, you're going to have a goldhen.h file that you can put right back into your project to compile and then upload back to the chip. Okay, so back over on the main project, we're going to need to pull in a couple of different libraries to start with. So let's go Sketch. and let's go to include library, and we're going to go to add zip library. And so remember that async TCP and that ESP async web server. Now we're going to need to select on each one of these to add these to this project. So we'll start with the async TCP. Okay, that one's been loaded. And now we're going to include another zip library, and we're going to select the ESP one this time. And that has now been added as well. Okay, and so I like to leave errors in here because if I hit it, more than likely you will too. So I'm going to go up here to the top and I'm just going to click on this upload button here. And what it says is it says that it is compiling the sketch. You'll see here where it says serial port COM6 and then connecting. And well, it actually is not able to connect. And you will get this error message, and that is simply because you have not set the device into the programming mode, which we will cover in just a moment. Okay, so I want to go over the settings for the device now. So let's go into Tools. And the first thing is make sure you have the ESP32-S2 dev module as your selected board. For the upload mode here, where it says UART 0, this needs to be changed to the internal USB. So make sure you make this change here. So internal USB. And then if USB CDC on boot is enabled, just go ahead and make sure that is disabled. And then for the rest of these settings here, just make sure that they look identical to mine. The only other one that you may have to modify may be the PS RAM, and that being set to enabled. This was something they put inside of the instructions, so I just turned it on. It obviously works on mine, so hopefully it works well on yours. And I also wanted to add in a bit of a visual guide here for those of you that have ESP32 devices and are trying to get them into the programming mode. So here is my device manager, and let's go ahead and let's get this into the programming mode. Okay, so at this point, even though it has a little warning sign, the ESP32-S2 is in programming mode. So now you could upload successfully to this device. And then when it is finished uploading, you can simply unplug it. And also keep in mind here that the port section of the device manager will show the current port that your device is running under. So mine is on COM7 right here. And that should also match again to the tools, and then the board as well as the port should be showing as COM7. And again, now you should be able to go to the upload section here, and once all of that is complete, it should upload to your device successfully. So at this point, the absolute best thing to do is to now just unplug the device from your computer, and you can pretty much plug it directly into your PlayStation 4. And so now if you go ahead and you connect to that Wi-Fi access point, then you will see this if you just go to the 10.1.1.1. So obviously Goldhen is loaded and available, and also you can set the fan threshold. What we're going to need to do is we're going to need to go to the admin menu here. So let's just add on a /admin.html here. And there is the main page, which tells us a little bit about the software, the board, flash chip information, and so forth. And where we need to head over to is going to the file manager. And in file manager, we're going to go to the file uploader page, and we're going to select different files. So here is all of the different payloads that's currently available for you. I'm going to select a couple of these, so such as disabling the updates. I'm going to go ahead and grab app to USB. I'm going to grab appdumper.bin, and then we might as well go ahead and grab the history blocker and then hit OK. And now we're going to upload these files. Okay, so now we have our device pretty much ready to go. Let's go ahead and let's switch over to our PlayStation 4 and give it a whirl. We're going to go ahead and begin here by going down to Network, set up an internet connection. We're going to use Wi-Fi. We're going to Custom, and then we're going to select the PS4_web AP. Since I've used this before, I don't have to enter it, but there is a password, and the password is just password. So for IP address settings, we are going to go automatic and do not specify, and then manual for the DNS. And I am just using a primary DNS of 10.1.1.1. And then we're going to go next here, automatic, do not use. And now going back up to user guide, helpful info. And one other quick thing to note before we do this is that you probably want to go into your web browser and go ahead and delete the cookies and clear the cache before you run this, especially if you've used previous versions of this before. All right, so now go to the user guide. Here is our server, and there is the payloads that we have added to the device. I'll go up to Gold Hen 2.1.2, and basically here is our exploit. I will fast forward through this part since you've already seen it before, but it's super fast. And so there comes the pop-up message, and then we are complete. And keep in mind, there was no alert boxes or anything that popped up that delayed us from getting to this point as fast as we possibly could. And if I wanted to go ahead and run a payload, I'm just going to jump in here and I'm going to take the disable updates payload. All right, disabled updates. And so now we are good to go. So there is a payload being executed as well. Okay, and so there are a few other tweaks that you can make. So again, already having the project loaded up, if you scroll down just a little bit, you will see that you can connect to your Wi-Fi. So here you just need to punch in your SSID as well as your password here. And it does have, this is your Wi-Fi host name. So PS4.local is the default, which you can obviously change this. Maybe you have a PS4 living room. Maybe you have a PS4 office like I do, or a PS4 bedroom. This would be a great way to kind of differentiate between the two, especially if you have multiple chips for multiple PS4s in your home. Another thing that you may want to pay attention to is the USB wait time. So by default, this was set for 10 seconds, so 10,000 milliseconds. In my instance, I've modified mine and played a little bit around with it, and I've settled it around 3,000. I'm not saying you should do that. I'm just saying that 3,000 is one of the options that seems to work fairly well for me. Now, if you change this number right here, you will need to go and look down inside of the code and find where this is being called, because there is a if-then statement that you may need to either comment out or adjust. So right here is where that statement is, and it basically is resetting. So if somebody sets the USB wait time to less than 5,000, then basically they just put it back at 5,000 to correct unrealistic timing values. And then obviously if you set something greater than 25,000 or 25 seconds, then they just reset it back to 2,500. I've just commented both of these out on mine because the value that I put inside of my USB wait is the value that I want the system to use. So maybe that helps you out too. I hope this video helped. I am very happy with my S2 mini device, and there's also a bunch of other cool things that you can do with that device, such as like creating and using a case. Doyle has a couple of different cases that's already out there that you can use if you've got access to a 3D printer. I've actually ordered a couple of these cases myself that I will show here on the channel, so hopefully others are able to take advantage of some of the work that others have already done. If you got anything out of this video, or if this video helps, be sure to leave me a like here and go ahead and smash that subscribe button. I really appreciate the growth that this channel has had, especially over the last couple of months. It's went well and far beyond my dreams. of having this many people watching some of my content, especially on something that I love as much as I love console hacking. So thanks so very much for watching, and I'll see you on the next one. Michael, out.